Hello everyone. This video is going to be an overview for all the objectives that we have taken throughout semester 1, and we are going to take some examples to clarify things for you. Okay? Hope you enjoy it. Our first objective is the millions. So we are going to introduce the million class. But before I start, I'm going to remind you of the classes that you took before. The first class, which is the simple unit, or in another word, the ones. And you have to know that each class is composed of 3 digits. The second class that you know is 1000, and it's also composed of 3 digits. Today we are going to introduce the million class, which is also composed of 3 digits. What are these digits actually? They are ones, tens, and hundreds. And I have 1000, 10,000, 100,000, and today we are going to introduce 1 million, 10 million, and 100 million. Okay? Let us look for this number. If I want to decompose this number into classes, I just count them 1, 2, 3. This is the first class. 1, 2, 3. This is the second class. This is the simple unit. This is the 1000. And today we introduce the million class. A number could be written in 3 forms. What are they? The standard form, or in another word, in numbers or in digits, okay? Where I write the number in its number form. The second form is the expanded form, where I put the number to indicate its place. For example, the 6 here, it's in the 100 million, so I just write 600 and million, which are 6 zeros plus till the end. Okay? So this form actually indicates the place of the number, the place value of the number. Okay? The third form is the word form, where I write the number in letters or in word form. Okay? So, look at this, from standard form to word form. So I have a number which is written in standard form, and I need to write it in word form. Listen carefully to the steps. If you follow the steps, you are going to write the number in its correct form. The steps are to decompose first the number into classes. Why? Because it's going to be easy for you to write it. This is the simple unit, this is the 1000, and this is the million. Look, what do? You look for the million class. What do I have in the million class? I only have 8. So I write 8, then followed by the class name, which is million. Now what's the second class that I have? 756. So I read it as it is, and I write it as it is. So it's 756 followed by the class name, which is 1000. Now what do I have? 324, but we don't write ones. This is a silent class or silent family. Okay, now if I have already the number written in word form and I need to write it in its standard form, the first step and the most important step is that you have to put the class name in a box that you know. Why? Because, for example, you know that I have the million class. That indicates that I have already the simple unit and the 1000 and then the million. Look just before the word million. What do I have? 633. So I write it 633 in the million class. What do I have in the 1000 just before it? 3. It's in the ones, so I put it here, and the rest zeros. What do I have in the simple unit? 5. It's in the ones, and the rest zeros. Okay? So if you don't circle the classes, you are not going to know how many actually classes do you have. Now if I have them in the standard form and I need to write them in the expanded form, you need also to decompose the number into classes. For example, I have the 8 in what place? It's in the 100 million. So actually it's 800 million plus the 3 is in the 1, we don't put the 0. Okay, the 3 is in the 1 million, so it's a 3 million. And so on until I reach the 3. Okay, now if I have the expanded form, I need to write it in standard form. What do? I look for the 7. Where's the 7 found? Oh, in the 100 million. So I just put the classes, the dashes in this way. And the 7 is in the 100 million. What about the 5? The 5 is in the 1000, so I put it in the 1000 place. The 20 in the tens in the simple unit class, and the 7 in the ones. What about all the empty dashes? They are 0. So every time you need to write the number in any form, it's very easy for you to define how many classes actually do I have. Okay? Now the second objective is calculating mentally. Well, mentally means it's the ability to find the product without performing the whole operation. So for example, I'm not going to put 1000 times 250 and multiply, no. Okay, I'm going to search for an easy way to find the product without even performing it. How? If you look at this number, well, you see that I have 1000. 1000 is a multiple of 10. So it's every time easy for you to multiply if you have multiples of 10 because you have zeros. Okay? So the steps are just put the zeros in a box. Okay? Multiply the numbers. 25 times 1 is 25. And then you add as much as you have zeros in the box. So I have 4 zeros in the boxes. So I just put them all beside the number. That's it. It's very easy way to find them. Look at the second one. The second one also I have here 3 zeros and 2 zeros. I just put them in a box. 6 times 3 is 18, and then I put 5 zeros. Okay, but if you look at the third one, you don't have multiple of 10. What do? It's easy. You have to know that 25 times 4, so you have to look for the two numbers. If you multiply them, you get a multiple of 10. You know that 25 times 4 is 100. So 100 times 630, and then you follow the steps that you know. You put the zeros in the box. 1 times 63 is 63, and then you put 3 zeros. Okay? Our third objective is about rounding. Look at this axis. It contains number from 0 to 10. Okay? Suppose someone is standing on number 2. Do you think he is close to 0 or close to 10? He's close to 0, of course. But if someone is standing on 9, he's close to 10 than to 0. How can I know what are the steps? We are going to learn them. This is called rounding. So when I need to round is I need to check where's the number close to. Is it close to the number just before, or is it close to the number just after? For example, suppose I have 654 and I need to round the 5. I just underline the 5. This is the first step, is that you need to underline the number you are trying to round. The second step is you look just before the 5. What do I have? 4. Is 4 close to 0 or close to 10? It's close to 0. So if it is close to the number just before, I just keep the underlined digit as it is. So 6, 5. What about the 4? The 4 becomes 0. So everything to the right after the underlined digit becomes 0. Another example. Suppose I have 7, 8, 3 and I need to round the 7. I look to the number just before the 7, which is 8. 8 is close to 10 than 0. So I add 1 to the 7, it becomes 8, and also everything to the right becomes 0. Let us see the steps. So the first thing you need to do is to underline the number you need to round. The second thing is you need to look to the number just before it. If the number just before is 5 or above, you add 1 to the underlined digit. If it is below 5, you just keep the underlined digit as it is. But in both cases, all the numbers to the right of the underlined digit becomes 0. Let us take this example. Suppose I need to round the 7. I just look at just before the 7. It's 8. So 8 is above 5. So yes, the 7 becomes 8 and all the right part becomes 0. And now we are going to talk about the distance from a point to a line. Okay, suppose that I have a line and a point, and I need to find the shortest distance, from this point to the line. You can go like this, you can go like this, or you can choose any path. But to find really the shortest distance from this point to the line, you need to draw a perpendicular line from this point to the line. It should be perpendicular because this line is the shortest. We call it the shortest distance. Yes, you have a lot of paths, but the shortest distance is the only line which is perpendicular from this point to the line. But how can I know that this line is perpendicular, or how can I draw this line? So as we said, the distance is to draw this perpendicular line. Okay, but how can I know that this is perpendicular? I should use something called set square. It's a geometric ruler. Using this ruler, I can draw exactly a perpendicular line. Look, how is it? See? So this is the ruler. This ruler have a short side and a long side. You should always put the short side on the line, and the long side should be always passing through the point. So as you see in the figure, this ruler, we put the short side on the line and we let the long side passes through the point P. So we put the ruler on the line and we start moving until the long side passes through the point, and then we draw this line. This line is definitely the perpendicular line and we call it the shortest distance. Okay? So without the set square, you are not going to draw the perpendicular line, the exact perpendicular line. Okay? Location of a point on a graph. Before we start, you can see this grid. This grid is composed of horizontal lines and vertical lines. Okay, suppose that we have those lines. If you see, it's like the ruler. You have the 0, 1, 2, 3, 4, and so on, as much as you need, and also the vertical line. If you see, this is the first vertical line. This is the second vertical line, and so on. This is the first horizontal line. This is the second horizontal line, and so on. If you see, I have an intersection point of those lines. What do we call them? They are points. Okay? So if I want to define a point is formed from the intersection of a vertical and a horizontal line. So any vertical and a horizontal line, they intersect at something, we call it a point. So yes, a point, it has a vertical line and a horizontal line. For example, suppose the point 3, 4. When I say 3, 4, I mean that it is found on the intersection of the third vertical line with the fourth horizontal line. Let us check it together. Horizontal line. Let us check. Okay, let us look for the third vertical line. This is the third vertical line, and this is the fourth horizontal line. Where did they meet? This is the point. This is the point P. Okay, and any point you need, for example, if it is already located, suppose that I want to know this point, let us call it M. Okay, and I need to find its coordinates. So what do we call those two? We call them coordinates. So I look first for the vertical line. It's located on what vertical line? Oh, it's the 7 vertical line. On what horizontal line? Also 7. So it's M, 7, 7. So any point, it has vertical line and horizontal line. Or in other words, it's the intersection actually of those two lines. Look at this interesting title, add then round, or round then add. What does that mean? We will talk about it. Suppose I have those two numbers, 8, 7, 5, plus 1, 7, 3, 2, and I want to find the exact sum. 5 plus 2 is 7. 7 plus 3 is 10. 8 plus 7, 15 plus 1, 16. 8, 9, 10. So this is the exact sum of those two numbers. Let us round this number to the nearest 1000. What do I have here? 1000, so I go directly to the 0 and round it. What do I have just before it? 6. What does that mean? I need to add 1 to the 0 because the 6 is above 5 and all the right part becomes 0. So it becomes 1, 1 and 0, 0, 0. Good, cool. Look what we are going to do. What we did now is add, then round. Now what we are going to do, we are going to round, then add. Look, what does that mean? Round the numbers. Let us round the number to the nearest 1000. What do I get? 9000. Round this number to the nearest 1000. What do I get? 2000. Now let us add, because they said that I need to round, then add. Let us add those two numbers. What do I get? 11,000. Look, is it the same as the first result? Yes. So what does that mean? If you add, then round the sum, or you round, then add, you will get the same result. Okay? Addition and subtraction of whole numbers. So we are just going to review the steps of adding two numbers. The first thing is to put the number, the first number above. It should be the bigger. Then you put the ones under the ones. So here the ones is 6 and here the ones is 4. So you put the 6, the 4 below it, the 2 below the 5 and the 1 below the 4. That's what we call the ones under the ones, the tens under the tens, and the hundreds under the hundreds. And what do? I add them starting from the right. So 6 plus 4 is 10. 5 plus 2 is 7, plus 1 in hand is 8. 4 plus 1 is 5 and 3. That's it. So if you aren't going to put the ones under the ones and the tens under the tens, you will not have a correct answer. Okay, let me tell you something. For example, 2 times 6 equals 12. What does the 12 represent for the 2 and what does the 12 represent for the 6? The 12 is found in the multiplication table of 2 and the 12 is found in the multiplication table of 6. What do we call them? Oh, I said multiplication table. So what does the 12 represent? The 12 is a multiple. So what do we call the 12? Is the multiple. Why do we call it a multiple? Because if I multiply the 2 by 6, I get 12. But what do we call the 2 with respect to the 12? The 2 is a factor. So what's the meaning of a factor? A factor means, yes, it divides the 12. So the factor means it's the ability to divide. While the multiple is, in another word, if we multiply this number by another number, we get the 12. For example, if I tell you 25, who can, or think just a minute, 25 is a multiple of what? Just think. You will find that it's a multiple of 5. Okay? So it's very easy for you to know that a multiple is a number. Whenever you multiply two numbers, you will get it. For example, if I'm asking you for a multiple of 3, you have many, but I'm going to choose for you, for example, the 2. 3 times 2 is 6. So 6 is a multiple of 3 because 3 times 5 equals 6. So the 6 is a multiple of 3 and 6 is a multiple of 2. You should know that the 0 is a multiple of all numbers. Why? Because 0 times 1, 0. 0 times 2, 0. 0 times 3, 0. So the 0 is a multiple of all numbers because if you multiply the 0 by any number, you will definitely get 0. Now let us take this example. List the multiples of 2. You should always start by the common multiple of all numbers, which is 0. Now, 2 times 1, 2. 2 times 2, 4. 2 times 3, 6. 2 times, and so on. You will have many numbers because numbers never end. Okay?